Right. So we talked about ultrasonic transmitting receiving. We talked about now surface acoustic waves. Now, these sensors or the sound waves can also be used as what we call a tuning fork sensor. Right? So you could have a resonance circuit, piezoelectric crystal to create a certain resonance. Now, these tuning fork sensors produce a very pure fundamental frequency of sound. Obviously, when the fork is going in one direction, it is a region where there's a lot of sound. When it moves away, there's a low region, so you have this kind of nice AC waveform. When this tuning fork is inserted into a liquid of a certain density and viscosity, generally, if you talk about density, the frequency will change. The fundamental frequency will change, as well as the amplitude. And if you're thinking about the
damping will change.
For the density, I think the fundamental frequency will change. For viscosity, the damping will change.
Correct.
Right? So here it's density, and if you're talking about viscosity, we're looking at some kind of a difference in the damping frequency. So this resonance circuit produces a fundamental frequency. Now, when you put this fork inside a liquid medium, this fundamental frequency will change according to the density of that fluid, of that liquid or fluid, and the viscosity is related to the damping. Which we can see here. Right. So
in the magnitude and phase plots.
In the magnitude and the phase plots coordinates here. Boby, I think
imagine.
This is a very common picture that you see if someone talks to you about ultrasound, they will most of the time we will talk about their baby.
Correct.
Right. So ultrasound is a very, very old kind of technique that uses sound waves to image inside the body. And this here, obviously you can see a woman is being her baby is being shown on a sonogram where we use ultrasound detector. Now, generally, ultrasound.
It's a very similar principle, like you are shown the distance measurement or defect measurement.
Yes.
Looking at the reflection.
Exactly. So I think inside the body you have many different things like tissues and liquids.
Different layers.
There will
be deflection
from different layers, and then based on that, and also they have different impedances. Correct. So based on that, you can basically image what's inside. Obviously, inside the body there are lots of things that could happen. There's attenuation, reflection, refraction, absorption, scattering, and many different things. But obviously, we also know most of the organs inside the body, on the tissues and the liquids. So if we know the impedances of these different tissues and things inside the body, we should be able to accurately kind of image using ultrasound principles. And here it's a small mistake here. This is ultrasound imaging, right? So this should be ultrasound imaging. Okay.